Chapter 8 is talking about confidence intervals. And confidence intervals is also an important section, picking up from normal distribution and from central limit theorem. What we're doing with a confidence interval is we're trying to set an interval, to predict an interval around a parameter to come up with a good interval estimator. Now, we can do calculations that are called point estimates that come up with a single estimate, but when we're talking about confidence intervals, we want to come up with a range or an interval to try to test these, and it is going to be an estimate with some degree of error built in. We'll oftentimes talk about the level of confidence or the confidence interval, and typically in introductory statistics, any statistics, we either deal with a 95% confidence interval and sometimes a 99% confidence interval. Occasionally you may see a 90% confidence interval, but you can actually calculate any confidence interval you choose, 96%, 97%, but typically we see 99 and 95, which also correlates to the degree of error. If we have a 95% confidence interval, then the level of significance of the error is going to be 0.05. So A1 walks us through a very common type of confidence interval, estimating population means where sigma, standard deviation, is known, and they walk you through the formula there. We're still now going to be using z-statistics because we are dealing with normal distributions that are typically large and known. And you can see the formula there on page 432, x bar plus or minus the margin of error. And the margin of error is calculated there on 431 as the z value. And because we are dealing with essentially a two-sided test, it's going to be the level of significance alpha divided by 2. So you find that from your z table, times the standard error of the mean, sigma x bar. And then from that we can calculate the confidence interval for the population mean, because sigma is known. And again, we're coming up with a estimate about a fixed value. So be careful in your language. We're not essentially determining, say, a 95% chance that the population mean will fall within this range. That's not the proper way to talk about it. We're going to say we're 95% confident that the population mean, which is a fixed value, will fall within our interval that we're trying to estimate. And there's also, of course, ways you can do this on the scientific calculator that makes things a little bit easier. Now 8.2 introduces something new and very important to us. It's the student t-distribution. So if you flip back to the back cover, you'll see it says critical values of t on the back cover. And what we're doing with the t-distribution now is we're using a slightly different curve, the t-distribution curve, as opposed to the z or the normal distribution. And this is going to apply when either we're talking about a non-normal distribution or when we're dealing with a normal distribution in small sample sizes. Traditionally, you think about sample sizes less than 30 or small sample sizes utilize the t-distribution. It's very similar to what we did in 8.1. But now the formula changes just slightly. Specifically, the formula now is going to use obviously the t values from the t table, and that's going to change things. A lot of what they work us through here is with a calculator. But you can simply just change the z's to the t's, and it should be able to work out just fine if you use it with the equation. As I said on the calculator, yeah, if you have the especially the 84 plus silver edition, you not only have the inverse normal key, but you have an inverse t key that helps as well if you're trying to calculate these values. In 8.3, they now change things slightly. You estimate the population mean, but now sigma is unknown, so we're going to have to use the estimate of sigma, which is S, which is the sample standard deviation. And to do that, we're also going to have to invoke the t distribution as well. So the t is going to be used here in 8.3. The formulas are again very similar to what we had in 8.1 and 8.2 to try to come up with this confidence bound or interval. And then 8.4 gets us into estimating population proportions. Now we're back to the z. When we're dealing with proportions, we're back to the z values. And then in 8.5, a little bit different, estimating population variances. I know in my graduate math statistics course, this was a particularly nasty proof to work through when we're dealing with population variances and coming up with these intervals, but there's some intuitive nature to it as well. The chapter also makes good use of trying to figure out the minimum number of samples that we need in various problems that we work. So if we're trying to figure out what's a minimum sample size that we need to come up with a confidence interval that's statistically significant or usable, there are several places here in these chapters where it allows us to calculate n for these different problems. You know, in 470, it's finding n for the proportion, and I know back in 8.1 they had a similar discussion where it walks us through finding n for just a general case, yeah, on page 438. So confidence intervals are important. Again, we're not coming up with a chance that the value falls in our range. We're just going to say we're 95% confident that our range will contain the interval. The problems are pretty straightforward. I mean, if you're going to work some of them by hand, which I encourage, it's going to take you just a few minutes to work these by hand. I suggest that you absolutely work several of these by hand. Once you have it mastered, then I strongly suggest you use the calculator and be sure that you can use the graphing calculator also to work these and be very fluent with confidence intervals in the calculator. You need to be able to seamlessly go back and forth. Okay, that finishes up chapter 8, and this is the last chapter for exam 2. And then after exam 2, we'll continue with confidence intervals and move into chapter 9, which is confidence intervals for 2 samples.